Hello, and perhaps also welcome back to the second installment of AngularJS for the people. In this video, we will be exploring the AngularScope object. The scope object is a JavaScript object that links the application controller and the HTML view. Understanding the scope object is of critical importance to becoming an Angular developer. For this reason, I decided to prepare a video module exclusively on this topic. There is much to learn about the scope object. Scope is a very important part of the Angular framework, and as such deserves special attention. The scope topics I will cover in this video include a more formal introduction to the scope and the rootScope objects, understanding how an Angular application can generate multiple scopes, and using developer tools to help you understand and work with scope. Since an Angular application can create multiple scopes, we will explore the hierarchical parent-child relationship of scope, as well as the associated prototypal inheritance they follow. We will also take a quick look at how scope objects are created during the Angular application initialization process. And to finish up, we will discuss how Angular updates the HTML view whenever the scope is changed. This is accomplished with the Angular Watch infrastructure, which is designed to observe model mutations on the scope object. If you have already watched my Angular for the People Part 1 Fundamentals video, then you know that the controller construct, as one of the three primary constructs of the Angular MVC framework, encapsulates the model data and exposes select properties and methods to the Angular scope object. As described very elegantly in the Angular documentation, the controller decorates the scope with functions and values. We also learned that the view is a representation of the model data carried by the scope object. Then, in the fundamentals video, we were introduced to directives and learned that Angular links the HTML view in a bidirectional manner to the scope object with these directive constructs. With this introduction, it should now be very clear what is responsible for the bidirectional transfer of data between the model and the view. Yes, the Angular scope object. It is responsible for this bidirectional data synchronization process. The Angular scope object is a traditional JavaScript object that binds properties and methods. The scope object references the properties and methods of the model with the help of the controller, and then binds this model data to the view through directives. Hence, the scope hosts the data for the view as it links the view with the model. Both controllers and directives have reference to the scope, but not to each other. This arrangement isolates the controller from the directive as well as from the DOM, making controllers view agnostic. Please note that the scope is not the same as the model. The model is an MVC construct that is hosting the application data. Scope is a JavaScript object that binds the model properties and methods to the HTML view. Both controllers and directives reference the scope, but do not reference each other. There is no direct link between the controller and the directives. This is the job of the scope object. This arrangement isolates the controller from the DOM, the directives, and the view. Let's examine what scope exists within an HTML-only Angular application. This HTML-only Angular application has no JavaScript component other than referencing the Angular library in script tags, and hence in this example there is no creation of an Angular module by us or registration of a named controller. When the Angular compiler encounters the ng-app directive, it starts the application initialization process known as application bootstrapping. Everything within the div containing the ng-app directive is declared an Angular application. Also, thanks to the ng-app directive, Angular will create a global scope object called rootScope. rootScope is a global object and is available to every element defined within the Angular application. Every Angular application has a rootScope. Just like any other JavaScript object, rootScope hosts properties and methods. Since the ng-app directive, which is added to the div element as an attribute, does not have an associated value, nor do we create a named Angular application module, our mini application here can be considered an unnamed Angular application. In our unnamed application with no application module and no controller created by us, the ng model directive binds a property named dog to the rootScope and links it to the input element value, setting up two-way data binding. The rootScope object will bind the property dog as soon as a string is entered into the input element field in the UI by the user. rootScope.dog will be defined. The value of this rootScope.dog property can be altered when the user enters a value into the input element text field. This is an example of two-way data binding, as the value associated with the input field is bidirectionally linked or bound to the rootScope property declared by the ng model directive. And this property is dog. rootScope.dog equals whatever the user enters into the input field. The value of rootScope.dog can be rendered to the view by one-way data binding, and there are two ways to achieve one-way data binding. First, by adding the rootScope property you would like to view into the double curly brace interpolation symbols. Or by adding the ng-bind directive to an HTML element and adding the rootScope property whose value you would like to see in the view as the attribute value. The ng-bind directive or interpolation symbols will enable you to access scoped properties in a one-way manner. Let's observe our application in the browser. I will use the Angular developer tool called ng-inspector to dynamically observe scope behavior in action. ng-inspector is available at ng-inspector.org. ng-inspector is a browser extension for Chrome, Safari, and Firefox that adds an inspector pane to help you develop, debug, and understand your AngularJS applications. Back to our application. Adding a value into the input box adds the property dog to rootScope and changes the scoped value with each keystroke. The scoped property can be rendered to the view with either ng-bind or interpolation symbols. At this point, I would like to inject some additional information regarding directives. Up till now, I have referred to directives as an extension of the HTML vocabulary that can be added to HTML as attributes. The official definition of Angular directives is that they are markers on a DOM element, and as such, the Angular directives can be added to HTML in a variety of forms. They can be added as attributes, HTML elements, comments, and even CSS classes. This slide lists most of the currently available built-in Angular directives. Most of them are attributes, but some of them are also HTML tags that are recognized by Angular and provide new functionality to the HTML element or the DOM element. A great way to see how these directive markers work is to start up your browser's Developer Tools window and take a look at the element details. Here we can see the div containing ngapp also now has a class of ngScope. Angular has placed the ngScope class in this element that will create a scope. ngScope is an Angular directive for extending scope. It is automatically added by Angular to directives that create scope. And hence Angular has marked this element as one that will be creating a scope object. We have already learned that ngapp creates the rootScope object during the application initialization process. Also notice how the H2 elements containing ngbind and the interpolation symbols, which as we know both declare one-way data binding, in both cases Angular has added the ngbinding class. This is done automatically by Angular, and you will not have to do this yourself, but it is good to be aware of how these directives work. There are a variety of directives that create scope. ngapp creates rootScope. There are other directives that can also create scope, and the first such directive we will look at is ngController. Here is the angular.org documentation page for the ngController directive. Under Directive Info, it states that this directive creates new scope. ngapp creates the rootScope, and this object is global and available to every element defined as an Angular application. ngController also creates a new scope. This scope can be referred to by the name assigned to the controller in your application module object, and also included as the ngController attribute value. In this case, myCTRL for my controller. So our new scope created by this ngController directive can be referred to as myCTRL scope. Unlike the rootScope, which is available to the entire Angular application, hence all view elements included in the Angular application, the myCTRL scope is exclusively constrained to the view element containing the ngController directive with the myCTRL value. In the HTML above, the dog property that is tied to the myCTRL controller will only be available to the element containing the ngController directive with the myCTRL value, and not to this h1 element that is outside of the ngController div. The dog property value, which is woofers, will only be rendered in the h2 element by one-way data binding and not in the h1 element, as the h1 element has no link at all to the myCTRL controller. Considering the rootScope is global and available to the entire Angular application, and the myCTRL scope is constrained to the view element that declares it, the scope objects follow a hierarchical arrangement resembling the HTML elements. This arrangement lends itself to a parent-child scope hierarchy. This makes rootScope the parent scope, and the ngController scope myCTRL scope the child scope. And it gets better. The child scope inherits from the parent scope by prototypal inheritance. Now that we have been introduced to rootScope and other scopes that can be created by directives other than ngapp, I would like to use Angular Developer Tools to interactively explore scope in our applications. There are two developer tools I would like to share with you: AngularJS Batarang and ng-inspector. We have already been introduced to ng-inspector, and Batarang is available as a Chrome extension. Here is the application I would like to explore using ng-inspector and Batarang. rootScope is created by ng-app, and the property puppy is added to rootScope with the ng-init directive. There is another scope created by ng-controller called myCTRL that is constrained to this div here. The myCTRL scope carries one property, dog, with the value woofers. Within the ng-controller div, we have two h2 elements. The first h2 element is bound to the dog property, which is tied to the myCTRL scope. The second h2 element is bound to the puppy property, which is tied to rootScope. Both of these bound properties, dog and puppy, should render to the view as the puppy property is available via the global rootScope and the dog property is available via the myCTRL scope, which is constrained to this div. Here we have another two h2 elements. Both will display in red text thanks to the red color CSS rule. The first h2 element is attempting to bind the dog property, but the dog property is tied to the myCTRL scope, which is not available to this element. The second h2 element is bound to the puppy property, which is available to it thanks to the all-available rootScope. Let's explore our application with its two scope objects using ng-inspector and then Batarang. Launching the application, we see that the dog property, which is bound to the myCTRL scope object, is only available to the element with the ng-controller directive, and hence only the h2 tag that is inside the myCTRL controller element will display the dog property, woofers. The dog property expression in the interpolation symbol outside of the myCTRL controller will not display the woofers value. The property puppy is bound to rootScope and hence available to all elements in the application with its value of barn. Launching the ng-inspector tool, we can see the two scopes of this application, rootScope and the myCTRL scope. The myCTRL scope carries the dog property and its value woofers. The puppy property is bound to the rootScope by ng-init, and hence this property is available throughout the application, and it carries the puppy property value of barn. The same can be seen with Batarang by selecting Developer Tools and then AngularJS. We can see there are two scopes associated with this application. The rootScope contains the property puppy with the value barn, and the myCTRL scope contains the property dog with the value woofers. With ng-controller, we experienced how to create multiple scope objects in a single Angular application. You may have already noticed how the scope objects we created were created in the context of the HTML view elements, and that they follow a hierarchical arrangement that resembles these HTML elements. This hierarchical arrangement of scope is revealed when using the developer tools ng-inspector and Batarang. The scope hierarchy has a parent-child relationship as well as an inheritance hierarchy that follows standard JavaScript prototypal inheritance. Indeed, the child scope inherits from the parent scope. These great statements about scope hierarchy can be found at the docs.angular.org website. Each Angular application has exactly one root scope, but may have several child scopes. An application can have multiple scopes because some directives create new child scopes. When new scopes are created, they are added as children of their parent scope. This creates a scope tree structure which parallels the DOM where they are attached. And the last one here, which I find very helpful for understanding the scope hierarchy and the existence of the scope object entity itself, scopes are attached to the DOM as the scope data property. I have 2 slides addressing scope hierarchy and associated prototypal inheritance. There are 2 forms of scope relationship I would like to discuss: sibling scopes and parent-child scopes. Let's start with sibling scopes. Sibling scopes are isolated from one another and hence constrained, or scoped. In this small application there are 2 div elements, each declaring a link to a separate controller and creating 2 separate scope objects. Since each of these div elements are at the same hierarchical level as each other, they are considered sibling elements. The scope created for each div element by the ng controller directives myCTRL1 and myCTRL2 also have a sibling relationship and are hence sibling scopes. The properties and methods of the myCTRL1 scope are tied exclusively to the div element linked to the myCTRL1 controller, and the same applies to the myCTRL2 scope. The properties and methods of the myCTRL2 scope are tied exclusively to the div element linked to the myCTRL2 controller. Remember that all scopes prototypically inherit from the root scope, and that an Angular application only ever has one root scope. Taking a look at this application with our interactive Angular dev tools will help depict the scope hierarchy and demonstrate the constrained nature of sibling scopes. With ng-inspector, we can see our root scope, parent scope, and 2 child scopes that are siblings, one for each controller, myCTRL1 and myCTRL2. Each scope carries an exposed function. myCTRL1 scope carries function 1, and myCTRL2 scope carries function 2. Function 1 is only available to the button element linked to the myCTRL1 controller. Clicking on this button triggers this function, myCTRL1 scope accessed, and function 2 is only available to the button element linked to myCTRL2 controller. Clicking on this button triggers the function 2 function, myCTRL2 scope accessed. If you attempt to call function 1 from the button element linked to the myCTRL2 controller, nothing will happen. This is because function 1 is tied to the myCTRL1 scope and is not available to its sibling scope myCTRL2. In ng-inspector, the sibling scopes are depicted as 2 scopes at the same hierarchical level. On this slide, we have an example of the parent-child scope relationship. One of the controller scopes is a child of the other controller scope. The div linking to the myCTRL1 controller is a parent, to the div element linking to the myCTRL2 controller. In this arrangement, the myCTRL2 scope is a child to the myCTRL1 parent scope. The myCTRL2 scope, as the child scope, will inherit all properties and methods from its parent scope, myCTRL1, with an exception you will see shortly. Function 1 and function 2 are both available to the div element linked to the myCTRL2 controller, even though function 1 is defined in the myCTRL1 controller. This is because of prototypal inheritance. Within our browser development tool, NG-Inspector, we can see the parent-child relationships of the scopes. rootScope is a parent of myCTRL1 scope, which is a parent of myCTRL2 scope. The button elements linked to the myCTRL1 controller have access to two functions, function 1 and another function named 1x. The button elements linked to the myCTRL2 controller have access to three functions, function 1 that is inherited from myCTRL1 and function 2 from the myCTRL2 scope, as well as its own method named function 1x. This makes two methods named 1x, one in myCTRL1 and another in myCTRL2. But what will happen when I click the myCTRL2 button to access function 1x? There are two function 1x functions. One is in the myCTRL1 parent scope, and the other is in the myCTRL2 child scope. When I click the myCTRL2 button element to call function 1x, we can see that it calls the function 1x method from the myCTRL2 scope. This is the inheritance exception I was referring to before. If the child scope has a property that is identical in name to a property in the parent scope, it retains the property defined to its scope and will not inherit the one from its parents, or in this case, the 1x. The myCTRL2 button will trigger the function 1x method attached to the myCTRL2 scope, and not the one attached to the myCTRL1 parent scope. All functions in the parent scope myCTRL1 are available to the myCTRL2 scope with one exception, if the child scope has a property or method of the same name as the parent. And now, for the king of element cloning and multiple scope creation, the ng-repeat directive. ng-repeat clones the element for each item in a collection and creates a constrained sibling scope for each. ng-repeat also binds the collection item property to each scope it creates. ng-repeat is a directive that both creates scope and binds to scope. In this application example, a total of 6 scopes are created. rootScope, myCTRL child scope, which is a parent to 4 ng-repeat child scopes. This is immediately evident when viewing NG-Inspector. We have the root scope as usual. We have the myCTRL scope with the puppies array, and sibling ng-repeat scopes for each pup in the puppies array. pup Mook, pup Niblet, pup Sammy, pup Koost, and pup Barn. So how and when do scopes get created during the application initialization process? Angular discovers the ng-app directive and begins the application initialization process. Angular loads the named module, if one exists, such as ng-app equals my app. Angular then sets up dependency injection, and followed by creating the rootScope object. Angular compiles the DOM for the entire contents of the element in which ng-app is declared. During compilation, all directives and interpolations are discovered. All other directives declared scopes are instantiated and binding between view, scope, and model is established. Please be aware that there are other directives that create scope. Here are a few examples: ngIf, ngInclude, ngView, ngMessage, and ngAnimateSwap. Please review the AngularJS documentation at docs.angularjs.org to learn more about these directives. To wrap up scope, directives, and data binding, let's quickly review. We now know that certain directives create scope objects, like ng-app and ng-controller. Certain directives bind to these scope objects, like ng-model. And some directives do both, create scope and bind to scope, like ng-repeat. These scope objects are created in the hierarchical context of the view elements. Scope references the properties and methods of the model with the help of the controller. View is bound to scoped model data through directives with one-way and two-way data binding. And scope is the data for the view and hence links the view with the model. There is still one juicy topic remaining regarding scope and data binding: the Angular digest loop and the watch infrastructure. What is the watch infrastructure? We have learned how certain data binding directives like ng-model, ng-bind, and interpolations synchronize scope properties to the view, and when these properties change, the new values are then synchronized to the view. How does Angular detect these changes in scope properties and then synchronize them to the view? The Angular watch infrastructure enables the HTML DOM to be updated when model data changes. There is an Angular method called $watch that is carried on the scope object, and this watch method is responsible for detecting changes or mutations to the scope model data in a process also known as dirty checking. Let's overview the complete watch infrastructure process. The watch process is dependent on events. Events activate the watch process. An HTML element that includes the ng-model directive will call the scope.apply method when the user enters a value into the UI text field. Scope.apply is invoked when events occur, and in this case the event is a keystroke linked to the input element. These events can include user interactions such as mouse and keyboard events, form field updates, AJAX calls, or timer functions. The scope.apply method will take an argument or an expression and then calls the rootScope.digest function. The rootScope.digest function will start the digest loop. Notice the digest method is a method on rootScope. This digest cycle on the rootScope propagates throughout all child scopes and checks for model mutations with the scope watch loop. If the scope watch loop detects a change in a property or function, a callback function named the watch listener is called. When the watch listener is called, the DOM is updated with the new value by the Angular framework. Angular does this for all watches, the watches that we create as custom watches, as well as the ones created by the framework to support data binding. Both HTML directives like ngbind, ngmodel, and interpolations use this watch infrastructure. When directives are creating new child scopes during the application initialization process, directives like ngmodel, ngbind, and interpolations are registering watches on the scope. These watches keep a lookout for any model property changes that are bound to these directives. Now that you have an understanding of the watch infrastructure and the digest loop, maybe this cartoon makes sense. Don't worry, I'm not sure yet either. Here is another visual depiction of the digest loop and watch infrastructure. Step 1. The user enters a value into the UI input field. Step 2. This input value property X is bound to scope by the ngmodel directive. Step 3. During entry of the value into the input field, every keystroke triggers the digest loop. Step 4. All changes between the old and new scope property X are detected by the digest loop together with the watch loop with each keystroke event. Step 5. The change detected by the watch loop triggers the listener callback function and updates the DOM with the new value for expression X in the interpolation symbols. The watch function exposed by the scope object allows us to register a listener that gets called when the scope property changes. The watch method definition looks like this. Parameter 1 is the watched expression. This expression is evaluated in the context of the current scope. If the watch expression value changes, the listener function is invoked. Parameter 2 is the listener function. This is the listener function you register with the watched expression. And parameter 3 is called object equality, determines how the inequality or the change is detected. The default value is Boolean false, in which case the strict comparison operator is used, which will be sufficient for us now. I have created a simple Angular application including a custom watcher. This simple application provides an example how to watch a scope property of your choice for changes and respond with a listener function. Within the myCTRL controller, a property called counter is added to the scope object and assigned the value of 0. Additionally, a scope.watch method is declared. The expression to watch is the puppy property. The puppy property is bound to scope by the ngmodel directive when a value is entered into the input element by the user. Each keystroke event will trigger the digest loop and the watch loop and detect a change to the puppy property. This change will trigger the listener function of the registered watcher and add 1 to scope.counter. When the listener function is complete, Angular will synchronize the scope.counter value to the h1 element with the interpolation containing the counter property. The counter variable starts out with a value of 1 as the listener is triggered once during the initialization process. With every keystroke entered into the input field, the listener function is adding 1 to the counter variable. Thank you very much for joining me in this overview of Scope. My next video will explore advanced Angular topics including custom filters, directives, services, and routing. If you are curious who all the puppies are, feel free to contact me at danielnicholas.com. Remember, study, 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 exercise, and be kind. See you next time.